Hi, in this video we're going to talk about proportion and variation. This, if you're using your book, this is section 7.5 and it's around page 350. All right, so what is proportion and variation? Well, let's find out. First of all, we have to talk about ratio. Ratio is a quotient of two numbers, so like A over B. And that's what we call a ratio. They could be different things, but a comparison of two things. A proportion is setting the two ratios equal, like AB equals CD, A over B equals C over D. Quotient means division, so we're setting up, this is a division bar here. A divided by B, same as C divided by D. Solve by cross multiplication. To solve these, we just simply cross multiply. Okay, how do we do that? Well, we're going to multiply diagonally down A times D equals, and then we're going to multiply diagonally up. Let's put an arrow in there. Then we're going to multiply those two, B times C. So let's look at a few problems and see how we do this. Well, we could do it very mathematically. X is, we would multiply these two numbers and then you have 4x and so on. I'm going to show you a little shortcut that's a little faster. X is, we're going to multiply two numbers that we see that are diagonal, 8 and 14, right? So we're going to multiply those two numbers together, and then we're going to divide by the number that's left, the 4. Write it like that. So this is 8 times 14 divided by the number that's left. It doesn't matter where X is in this proportion. So let's take a look at a lot of problems. Proportion is very useful. It's used in trig and different areas of math. It's a very common thing to solve, very practical. 8 times 14, we're going to do a bunch of problems, and you see, divided by 4. Notice I just put it all in one kind of application here. And let's see what we get, 28. So 28 is to 8, is to 8 as 14 is to 4. There's other ways to do it, but this is probably the easiest. Okay, let's look at this second example. Here X is in the denominator, but it really doesn't matter. We're going to multiply two numbers that are diagonal, X equals, and I like to write this down so I know what I'm doing, and divide by the number that's left. Somebody told me a long time ago, I think it was my father, that said, let the paper and the pencil do the work. Okay, so 40 times 27 divided by 30 is 36. Just that easy. 40 times 27 divided by 30 is 36. We're going to multiply these two numbers, divide by the 30. So find two numbers that are diagonal and then divide by the number that's left. All right, so let's try that on an actual problem. It says you buy a mummified piranha for 20,000 pesos in a gift shop for a friend. Why? I don't know. And you exchanged $120 for 237,960 pesos. What is the cost in dollars for this mummified piranha? Well, let's see if we can set this up by proportion. When we set this up, let's set up money, dollars, over pesos. So I like to write how I'm setting it up. So on this one, let's look at the second sentence. You exchanged $120 for 237,960 pesos. Okay. And what would that be equal to? Well, you paid 20,000 pesos, and we're trying to figure out how much that would be in actual dollars. So dollars is equivalent to 20,000 pesos. And that should give us our answer. So how are we gonna solve this? Well, we're gonna multiply 120 times 20,000, and then we're gonna divide by that 237,960. All right, so let's try it. Dollars equal 120 times 20,000 divided by 237,960. So go ahead and try it. You can pause if you want. Okay, I'm going to go ahead and do it. See if we can see this. $237,960. Okay, so this came out to be approximately $10.08. So we're just rounded off this approximate answer. So the number of dollars is equal to $10. So it was approximately $10 for this mummified piranha head. I guess that was, or fish, I should say. So I guess that's a pretty good deal. I don't know if you like those kind of things. All right, so that's what we mean by population. Let's try another one here. Proportion. This is kind of a tricky problem. So we're going to take a look at this one. Let's put this off to the side. Marine biologist captures 832 turtles, tags and releases them. Several months later, she captures 900 turtles, of which 7 have been tagged. Estimate the total population of turtles. Okay, kind of tricky. Let's see if we can set up a proportion. How should we set this up? Let's set it up as tagged over total. Well, let's go with the second sentence. She captured 900 turtles. That would be our total. And of those, 7 were tagged. We could have put the total on top and the tag. Usually you wait to put the total on the bottom, but it wouldn't matter. And this is equal to what? Well, where is the 832 going to go? At first, it sounds like that's the total number of turtles, and this is where students usually go wrong. But if you notice right here, she tagged them all. Then she released them. So these actually became tagged turtles. And so this is the trick. It's on the way to total, but it was actually tags. And the total is going to be on the bottom. We just use a T for total. Okay, so the total number of turtles, well, to find that, all right, total. To find that total, we're going to multiply 900 times 832, and then we're going to divide by the number that's left, the 7. See how nifty this is? And that'll give us the total number of turtles. Let's see. So let me put my calculator there. 900 times 832 divide by 7. You could do it longhand, if you wanted to. I came up with 100, and let's see what the book came up with if I'm close. 106,971. That's a lot of turtles out there. So the book rounded it off to about 107,000 tertals. Okay, so kind of a tricky little problem because it looks like at first the 832 should go with the total here, but it's not. They're tagged. So you have to be careful. Okay, the next thing we're going to talk about is variation. Variation is another way of doing these problems, but also it has, we can use it for direct variation. Most of the time, our proportion is easier, but we can also use it for a little tougher problems that are hard to write into a proportion. And so then we use variation on it. So let's take a look at a problem. There's three kinds of variation. There's direct variation, inverse variation, and joint variation. And we'll talk about each one. Direct variation is basically a direct proportion. That's usually the type you can set up as a proportion, but we're going to set it up a little differently. On all these problems with variations, we're looking for something called a constant of variation. Constant of variation. And we're going to let the letter K, because we don't know how to spell in math, stand for that. So there's three parts to writing this. Number one, we're going to write a formula. Number two, we're going to substitute into this formula and find K. And then number three, we're going to try to find the unknown that we're looking for. In this case, find Y. That's what we're going to do. So we have to write a formula first, find K, and then find Y. We get our formula from the first part of the problem. It's telling us what we're going to do right here. Y varies directly as X. So we're going to write that as Y equals, and here's where our constant of variation comes in, K times X, like that. That's our formula. If it's direct, it's always times. Direct is multiplying right there. Y equals Kx. Now we're going to try to find Kx, K, by substituting in these values. Y is 50. K we are trying to find, and X is 15. We're going to solve that by moving this 15, dividing both sides by 15. And that'll give us our constant of variation. Let's see what that would be. 50 divided by 15. 3.333. Okay, so didn't come out real nice, but we'll write it down. Or you could write 3 1/3 if you wanted to. You could write it as a fraction. But we'll go ahead and use the 3.333. And then we're going to find Y. So we found the formula, we found K, now we're looking for Y. So what we're going to do is start off with our formula again and substitute in what we know. We know that K is 3.333, but this time we want X to be 24. See, X changed. And now that should give us our Y value. And again, this is another way of writing times. So we got our 3.333 in our calculator. So we're going to multiply that by 24, and we get 80. And there's our answer. So you're probably saying, well, when do you ever use this? Well, circumference equals 2 pi r. 2 pi is your constant of variation. Pi is 3.14. So circumference is 6.28 r. This is your constant of variation, see. Area equals pi r squared. Pi, 3.14, is our constant of variation. R squared A. So we do use it a lot in formulas that we're probably not used to seeing, but we actually have a constant of variation, and we use it. So, most of the time it's easier to write this as a direct proportion, but I'm going to show you how it works on this problem right here. Let's take a look at this one again. You bought piranha head and a mummified piranha, 20,000 pesos in a gift shop. Earlier, you exchanged it for $120 and so on. Okay, first of all, we got to start out with a formula. So dollars is equal to some constant times the number of pesos. We have a kind of a constant that we're using. We didn't use it in this, but we're going to set up this problem the same way. And then from this, we had some numbers that we could substitute in to find that constant. $120 equals K times the number of pesos, 237,960. This isn't in your book. I'm just kind of showing you. Okay, and that should give us K if we divide both sides by 237,960. Kind of a big number to divide by. Let's see what happens. This should give us our constant, so we're going to find K. And that's what we're doing here on our next step. So 120 divided by 237,960. And it comes out to be approximately 0.0005. Let's get the number of zeros right. 1, 2, 3, right. And now we're going to actually try to solve the problem. We're going to try to find out how many dollars this costs. So we're going to try to find the cost in dollars. So we're going to start out with our formula, D equals KP. And we did all this work to find K, 0.0005. That's our exchange rate. And then this time the number of pesos is now 20,000. So we're going to put 20,000 here. And that should tell us how many dollars it's going to be. So 20,000 times this, that's already my calculator. Approximately 10.08, same thing we had before, huh? So dollars is approximately $10. You see? And there we got our exchange rate. Now, granted, this is probably a lot harder than the first way we solved it. A direct proportion, easier to set up that way. Product of the extremes equals product of the means. But it can be set up this way. Form a formula, find your constant of variation, which in this case is like your exchange rate, and then find the cost in dollars. A little bit tougher to solve it that way, but you can see it's the same thing we were doing. All right, we probably wouldn't use this then on direct proportion. It's a lot easier to do it that way. But let's see what the inverse variation is. Inverse variation is y varies, wrong one. Let me get my inverse variation. Drop over here. Inverse E. Y varies, assume D varies inversely as C. Okay, what that means is D equals K is always on the top. Inverse means that C is now on the bottom. That's our formula. And see, you don't always have to have X's and Y's. D equals K for a constant of variation over C. If D equals 3/4, so this is a little bit harder one, equals when C equals 2, find K. K over 2. So right away, a couple ways you could do this. You could change 3/4 to 0.75, right? 3/4. And it might be easier to use it that way. So you could do it this way, 0.75 times 2, which would be 1.5. Or you can do it with fractions. 3/4 times 2 over 1, 6/4, or 3/2. Both ways could be done. Let's go ahead. Most of you would probably prefer to use a decimal. So we use 0.75, K over 2. Multiply that out. K equals 1.5. Okay, so now we found our constant of variation. And the last thing, like we did before, we're at the formula, we found K. Now we're going to try to find D. Find D. And we're going to write our formula again. D equals K over C. And now we're going to, now we're going to plug in D equals K, 1.5. And our new C is no longer 2, it's 24. And this should give us D. D is 1.5 divided by 24. And we got 0.0625. It's kind of small there, but that's it. I don't even know where I got this problem from, but apparently this will work. Okay, so that's the idea of doing this problem. So it probably was easier to switch this over to 0.75. So it says, if D is 3/4 and C is 2, multiply those together. Let's double check if I multiplied it right. 0.75 times 2. Yeah, 1.5. And now we're going to use that as our constant. And this time now it was 24. Okay, the last type of problem we're going to work on is what we call joint variation. All right, let's take a look at this. This is where multiple things are happening. Assume y varies jointly. Jointly usually means we're going to multiply. Jointly means kind of multiply. But also is x squared and y. So that's where he's saying that we're going to multiply those together. X squared and w, excuse me. And inversely as x. So when we see the word inversely, that usually means divide. So y varies jointly. Let's write this down as a formula. Y varies is equal to x squared times w divided by, this should have been a z, I'm sorry. I think I typed this wrong because we wouldn't want an x here and an x here. This was z, I'm sorry. My mistake, I wrote it wrong, typed it wrong. Okay, if y equals 50, what's missing in our formula? The k. K is always on top, so we'll put a k in here. Gosh, we got a lot of stuff there. Y equals, y is now 15. we're going to get this straight one way or another. X is 2.5, and we're going to square that. W is 8. K is K. And in place of Z, we're going to put a 20. Ooh, looks kind of complicated, huh? Well, all we did is replace in our formula. We're going to, in this case, we're going to find K, find Elmo. Okay, we're looking for K, and we're going to try to find it. So let's square this. Let's see what we can do. 2.5 squared. Now you can either hit the x squared key. Hold that up so you can see. Yeah, no good. You can either hit the x squared key, which is faster, or you can raise it to the second power, times 8. And we're going to divide that by 20. And that gives me 2.5. So this would be 2.5K. We did all this right here. 15 equals. And now we're going to divide 15 by 2.5 to find K. Six. A lot of work. But now we know K is 6. See? Now we're going to start off with our formula again. And this time we're looking for Y. And to find Y, we're going to substitute everything we know. Well, we just figured out what X is, K is 6, but we have some new numbers here we got to put in. So this would be 8 squared, Y equals 8 squared. And W is now 7. And Z is now 14. And now we can find it. Well, we know 8 times 8 is 64. I'm just going to put that into my calculator right away. 64 times 7 times 6. And we're going to divide that whole mess by 14. Equals. It's a little blurry there, but that's better. 192. And there's our value for Y. Okay, one last problem. I know you. A dosage of a particular drug, this is said, is proportional to a patient's body weight. If the dosage for a 150-pound woman is 6 milligrams, what would the dosage be for a daughter who weighs 65 pounds? Now, what kind of proportion is this? Is this going to be direct, inverse, or is it going to be joint? That's the first question. Well, this looks like more or less a direct proportion. But rather than doing it as a direct variation like we did here, which is kind of time consuming, let's see if we can just set it up as just a regular proportion, direct proportion. It says this drug is proportional to a person's weight. So let's put the drug on the top and the weight on the bottom. So the person's weight is 150 pounds. We'll put that down here. And the drug we want to give is 6 milligrams. This is in milligrams. Okay? Now she wants to give it to her daughter, and the daughter is 65, or the doctor does. Daughter weighs 65 pounds. So what's the dosage of milligrams that we're going to give to the daughter? Well, let's find out. See, by setting it up this way, it's a little bit easier. So most of the proportions you're going to get are direct proportions. 6 times 65 divided by 150. So we're going to multiply diagonally down and divide by the number that's left. And that gave me 2.6 milligrams. So it makes sense if you gave this lady 6 milligrams, this child is a lot less in weight, so you would give that child 2.6 milligrams. There you got it. So we usually use direct variation sometimes, but most of the time we use inverse variation or joint variation when the problem's a little bit harder than writing just a simple proportion. But if the problem is easy enough to write a proportion, then you should go ahead and write just a basic proportion. All right.